what is the phase rule, or is also known as Gibbs phase rule. Gibbs was a scientist on you know they have given this particular formula. That's why they it is a kind of the honor the scientists have given to them. It's known as the Gibbs phase rule. So this is basically the phase rule. Okay, so what is the phase rule? All the changes which take place in the system consisting of the several phases in accordance with the external condition like the temperature and pressure. Okay, so I mean what the kind of changes is being takes place in phases. Okay, according to your temperature and pressure, or obvious, I mean if you are altering your temperature or either pressure, then you would be having the different phases. Okay, as I already known, as a very good example of water. Okay, if you, in the water you keep the pressure constant, okay, which is atmospheric pressure throughout. Okay, and if you raise the temperature of that particular water to the 100 degrees C, then it start changing their phase, right? So what does it mean? It means you have kept one thing, pressure constant, but you have altered the temperature. Okay, so this is the condition. This is the basically the the criteria. I mean, anything you can, if you change from the temperature and pressure, then you would be having the different phases. Okay, but not as soon as you have changed the pressure, but at a particular point, which is the critical point. So, corresponding to the any temperature, you would have the corresponding or critical pressure, and if you have kept the pressure constant, then you would have the corresponding to the every pressure, then you would be having your critical temperature. So if corresponding to every temperature, you would have or you are having the constant critical temperature, and reverse of that, corresponding to every pressure, then you are having the critical temperature. So for everything you are having the critical pressure and critical temperature. Okay, so this is known as your phase rule. Okay, so also called the Gibbs rule. This is the condition. I mean, how the phase changes is occurring according to the temperature and pressure. Okay, this is known here your Gibbs rule. How we can define? So this states that the maximum number of the phases, how many maximum number of phases that can occur, which may coexist under the equilibrium condition, is equal to the sum of number of components C has defined with the number of component and between the number of degrees of the freedom in the system. Number of what is degree of freedom? What is the degree of freedom? Degree of freedom means, I mean, how many the independent variables are there in your system. Okay. In case of, I have already made temperature and pressure, then you must have to fix one thing. Okay. So you cannot vary together both of them. If you have kept your temperature constant, then you can vary the pressure. If you have kept your pressure constant, then you can vary your temperature. It means only one thing. I mean, in this case, you are only 1 degree of freedom. Means you have to set both pressure constant. Then you can alter the temperature. And if you have set the temperature fixed, then you can alter that pressure. It means you are having only 1 degree of freedom. Okay, degree of freedom means the variable which you can vary directly without thinking about anything. That is known. I mean, they are not basically dependent on others. Okay, so which is known as your degree of freedom. So degree of freedom, okay, and component, okay, that will define you, okay, as your number of, I mean, the number of the phases. It is the number of phases which may occur, which may coexist under the equilibrium. Equilibrium is a very obvious condition. Without equilibrium, you cannot define anything. Okay, is equal to the sum of number of components C and between the number of degrees of freedom in the system. So this is how we have here. So P plus F is equal to C plus N. So N means what? N is the number of the external factors that we have going through. Okay. In case of here, this particular form condition, if you have a temperature and pressure only, then you can replace the N with 2. Okay, because these two are the external factors. What is the C? C is component. This F is your degree of freedom. And if we talk about the P, then P is a phase. So, adding a phases plus degree of freedom is equal to C plus N. C means the composition plus the external factors. But in case of if we modify further, okay, according to if that we have only the two conditions, that we have temperature and pressure, which is the external factors. Okay, then we are having this particular equations. P plus F is equal to C plus 2. Okay, but in case if you are suppose if we, if we take the example of the water as we are boiling, then we have only the one thing. I mean, we basically keep our pressure constant. Okay, so pressure is constant. It means you are having the only one thing which you can vary, which is temperature. So temperature is your variable things or external factor that you are rely on. So it means you can put n value as one only. Okay, in case of the boiling the water. Okay, so the boiling of the water, where the phase you are basically having the different phases as well, liquid to solid to liquid, ice to liquid, water, and water to steam or vapor. Okay, so in that case, this phase rule will modify like P plus F and then it's equal to C plus 1. Okay, so this is your formula for particular condition in which you are having the constant pressure. Okay, or in the in think about in a different condition where you are having temperature constant and you are varying your pressure. So the same formula will go with that. Okay, because you are, it depends, I mean, how many n's you are, I mean, n means the number of factors or external factors. So if you are the only the one and you could have the three as well, it depends on your conditions. Okay, so the number of degree of the freedom is the quantity of independent external. Yeah, here it is has been already. I have already defined you what is the degree of freedom. Okay, we change without the causing the disappearance of the phases or the formation of a new phase in the system. Okay, so this is what the things. Okay, I will discuss in applying the phase rule for the metal system. The effect of the pressure is neglected, leaving only one variable factor temperature. The equation would be like this. Already have made I mean, neglected means what? Okay, neglected means they have they are being constant. Okay, so in such cases where the pressure is constant almost, then you can modify the Gibbs phase rule to this one, like as F is equal to, and it's just a modification of these particular equations. Okay, you have kept this and you have taken out P from left to right. Okay. So in equilibrium, all factors have the finite values. Hence, the degree of freedom cannot be less than zero. Okay. So degree of freedom cannot be less than zero, right? So it would be always either it can, it could be zero, but not less than zero. Okay. So you are having this particular formula. Okay. And according to this, then you can see that P is less than always C plus 1. C is the compositions or components, right? How many components are there? So which shows that the number of the phases in the system cannot exceed the number of components. Do you understand? If number of component, how many number, if you have defined the number of components, it means your phases cannot be more than your component, right? So if component have the only the two components, then your phases must not exceed 3. If your component is 3, then your phases must not exceed the number of 4, right? So this is the idea from your phase rule. So this is a very notable things that how phase depends on your components. If your component is 1, then your phase cannot be more than 2. Okay, so it's a plus 1 as you can see here in this particular formula. So phase must be less than C plus 1. So it is, I mean, this is the maximum condition. Always you could have the less, but you cannot have more than one. Okay. Therefore, no more than 3 phases may be equilibrium in binary systems. In a ternary system, no more than the 4 phases may occur in equilibrium. Which means if you have a 3 components, a 3 component system, then you would not be exceeding the 4 phases. Okay.